example on the McClure. Okay, so you can read this question. So the neuron J receive input from four other neurons whose activity level are uh, 15, negative 15, 8, and negative 4. The respective snaps width of neurons J is the 0.7, 0.3, negative 1, and negative 8. Okay. The question is to calculate the output of neuron J for the following two situations. Okay, the first neuron is linear, and second one is the neuron is the represented by the McClure and Pitts. Right. So the first, right. So this is our neural, our neural. So we have four. Okay, we have four inputs. Okay, this means here inputs we can create as a x1, x2, x3, and x4. All right, so we can put here this output. Okay, x1 I declare as a 15. Okay, x2 negative 15. All right, x3 8, and will be negative 4. Okay, so this is for weight, and then for weight, weight 1 declares the 0.7. Okay, it means here will be 0.7. Okay, I put here as a weight 1, weight 2, okay, weight 3, weight 4. Right, so weight 1, weight 2 is a 0.3, weight 3 is a negative 1, and weight 4 will be negative 0.8. Okay, negative 0.8. Right. So the first question is the neuron is linear. Just straightforward lah. Using the formula. Okay. S equals to B plus submission of Xi Wi. So as we know, the mentioned here, the bias and threshold will be set is a 0 lah. We set to the 0. That means B is a 0. Threshold will be 0. Okay. So will be here will be submission of Xi Wi. Okay. So the first step, you have to calculate the S lah. Okay, S for the linear. S for the linear. Okay, X1 multiplied by okay, with 1. Right, and then plus 50, negative 15. Right, multiplied by 0.3. Okay, plus 8 multiplied by negative 1 plus okay negative 4, that is negative 0.8. Okay, and then you get the S. Okay, so you can try this one. Calculate 50 multiplied by 0.7. Okay, this is a 10.5 plus negative, okay, 0.3 is a minus, sorry, is a minus 4.5. Okay, minus 8. Okay, and then plus 4 multiplied by 0.8. Okay, 3.2. 3.2. So the total is 10.5 minus 4.5 minus 8 plus 3.2. So the answer will be S equals to 1.2. Okay, so if the neuron is linear, so automatically the output of our system will be same like input here. Okay, so the answer will be 1.2. Okay, that is for question number 1. So the question 1, y equals to, because we want to find the output. Output is the y here. We want to find the y. So this one is the S, but the output will be same. Okay, if the linear, so the output will be same with the S. So that is the answer for the question number 1. Okay, question number 2. Okay, so represent F the McClure and Pitt. So after we calculate this one, so we have to compare. So remember, for the McClure, we have the condition of y, right? So 0 and 1. Okay, if S greater or equal with threshold, so y equal to 1. If S less than threshold, y equals to 0. Right, so this one, we get the S is 1.2. Okay, 1.2, automatically y equals to 1. Okay, here, the question number 2 will be y equals to 1. same. Okay, the calculate the S will be same. All right, so S equals to 1.2. So straightforward using this one. And okay, for example, this is question number 1. Question number 2 will be straightforward. Y equals to 1 because of S greater than equal with threshold lah. So our threshold will be set at 0. So greater this S on S is the 1.2 greater than 0. So output will be 1. So that is the answer for question number 2. Okay, 2 here. All right. So next we go for the next question. Will be okay. Okay, still in the McLove. All right. So this is on the McLove, McLove. McLove and Pitts. All right. Okay, the first step that I mentioned to you, you have to calculate the S. All right. So calculate the S. So this one it will be input and all the weight set as 1 and threshold is a 3. Okay, first you have to know lah. The first step, calculate the S. Okay, that's formula for S lah. V plus summation of Xi Wi. Alright, so this one no bias. Okay, no bias here. So automatically will be S will be summation of Xi Wi. Alright. Then second step, you have to compare. After you calculate the S, the net input, so you have to compare with threshold. Alright, so the for similar like before this. Okay, if S greater or equal with threshold, Y equals to 1. Okay, if S less than threshold, Y equals to 0. Okay, so to get the output here. Alright, okay, that is the step lah for McLove. McLove is straightforward. Okay, straightforward. Just first calculate the S net input here. Okay, here lah we call it S here, and then compare with threshold. This one will be set threshold is the 3. Then the output will be here lah. Okay, output will be here. Okay, so we can check for first iteration. The first iteration, input 1. Okay, first we have to calculate the S. S for the input 1, iteration 1. I put iteration 1. Okay, so S equals to X1. Okay, X1 here, multiply by weight all 1. Plus 1, multiply by 1. Okay, plus 1 multiplied by 1 plus 1. Okay, Xn is also 1 multiplied by 1. Okay, so the total 1, 2, 3, 4. Okay, so 4. This means Y equals to 1. Greater or equal with threshold, Y equal to 1. So Y equal to 1 here. That is for the question number, iteration number 1. And then second iteration. Okay, I put here second iteration, same. Calculate the S. All right. So we use the second iteration. X1 1. No, this one no addition of weight. Okay, second 1 multiply 1 0 multiplied by 1 plus 0 multiplied by 0. Yeah, sorry, multiplied by 1. Okay, weight is 1. Weight is 1. Okay, so the S equals to 2. Alright, so that means S less than threshold. Our threshold is a 3. So Y equals to 0. Y equal to 0 for second iteration. Next iteration, third iteration, we can calculate here. Alright, so for third, same step. So calculate the S net input. Alright, so 1 multiplied by 1. The weight will be maintained. Weight will be maintained 1. Because this McLove and Pitt no addition of the weights. 1 multiplied by 1 plus 1 multiplied by 1 and that's 0 multiplied by 1. Okay, so 1, 2, 3. Okay, so 3. So equals same. So Y equals to 1. Okay, so Y equals to 1 here. Okay, so that is the McLove. Straightforward. If McLove is straightforward lah. Alright, so first you have to calculate the net input, the S, then compare with threshold. Okay, so if greater or equal threshold, y equals to 1. If less than threshold, y equal to 0. Okay, so this is for McCullough. Okay, this is for McCullough lah. Okay, we can go for the next. Try next. Okay, I think we can proceed for the next lah. Next is the herbs, because for the McCullough is straightforward. I have another example for the McCullough, but McCullough I think is straightforward. Maybe we can focus for okay, for the herbs. I think we'll focus for the herbs. With okay, so next we go for the herbs. We go for the herbs. Right. So these some example some example for the herbs. Okay, the first step similar like McCullough. All right. So McCullough, first we have to calculate the net input. Okay, the S. Okay, S equals to B plus summation of Xi Wi. This is a standard lah. Standard to calculate the S. Okay, the net input. But depends on the neuron. So this one we have the bias lah. That's why we have the B here. Okay, if don't have the B, the bias, so automatically S equals to summation of Xi Wi. Okay, so this one no comparison, no comparison, just straightforward. Okay, so this one, the next second, this one will be, you have to know lah, the condition will be y equals to t. So this one, third, you have to know the weight adaptation. So this one, weight adaptation new. This formula, formula for herbs learning. Okay, with all, okay, plus xi y. All right, and then for bias new, bias all plus y. Okay, that's formula lah. First, calculate the S, then calculate adapt the weight and bias. All right. So you can see this one. Okay, the initial weight here. Okay, 0.5. This one 0.5. This one 1, and bias is 1 lah. All right. So the first step, as I mentioned to you, you have to calculate the S. Okay, suppose maybe we can put another column here, another column here. Okay, for S. Okay, calculate the S for the first. But this one, you can straightforward. No need to calculate the S. You can straightforward adapt the weight and bias. Okay, but for follow the step, we have to calculate the bias lah. Sorry, the net input, the S. Okay, for first iteration, I go for the first iteration here. Okay, the first iteration S. Okay, the bias is 1. Okay, x1 1. Okay, weight 0.5. Okay, plus x. Okay, 0.5. Okay, the input 0. Okay, x3 0. Okay, x3 0, but the weight is 1. Okay, right, so will be 1.5. Okay, the S equal to 1.5. And then you have to calculate the weight 1, weight 1 new. Okay, weight old. Okay, weight 1 old is the 0.5. Okay, plus x1 here. X1 is 1. Y. Okay, let's see, y equal to t. Or maybe you can put another column here. All right, so maybe I put here. Okay, I add another one column here, equals to y. Okay, the condition of the McCullough, y equal to t. So this means will be same lah. Okay, so multiply by y equals to 1. Right, so 1, okay, 1.5. Okay, with here will be 1.5. Okay, 1.5. Then next, for second, with new 2. Okay, new old is a 0.5. Okay, x2. Okay, this is x2. X2 will be 0 and by 1. So the answer will be 0.5. Okay, so this one will be maintained, no adaptation. All right, so and then with 3, with new 3, okay, new O is the 1 plus, okay, x3 is the 0, okay, y. So the answer will be 1. So this one also no adaptation. Just follow the previous. Okay, and then bias. The bias new, bias old is 1 plus y. Y is 1. So the bias will be added 2. Alright, so bias will be 2. Okay. Sorry, this one here, 1.5 here. Suppose here, 1.5. Okay, so next for second iteration, okay, second iteration here, 1, 1, 0. So first you can calculate the S, what is the S, and then you can calculate the weights and uh, bias, but make sure so if you added the weight and bias, follow this one follow the, okay, I will go for example okay, so for S, okay, for second iteration, okay, here so that is the different here. So S is the, okay, bias is the new bias is a 2, okay, not 1 because we follow the previous iteration. So the first iteration we follow the initial, and then second iteration we follow the first iteration of weight and bias. So the bias will be changed to 2. Okay, that's why you have to remember this one. So some mistake of the previous student, they maintain on the initial, okay, initial value for weight and bias. That is wrong lah. For second step, for second iteration, you have to follow the previous, okay, previous weight and bias. That's why the weight for weight 1 will be changed, but weight 2, weight 3 will be maintained, and bias will be changed. That's why here will be changed. The S will be changed lah. So plus x1, x1 will be 1. Okay, weight 1 will be 1.5. So this one will be changed 1.5, not 0.5. Okay, second is a 1, right? And then weight 0.5. Okay, plus x3, the 0, weight 3 is a 1. Right, so the answer will be okay, 2 plus 1.5 plus 0.5. Okay, so will be 4 lah. Okay, S will be 4. Okay, this one will be 4. And then you have to add that for every weight. For weight new 1, new. Okay, so all will be, okay, this all will be 1.5. Okay, 1.5, not 0.5. Okay, not 0.5. This is initial. This is initial. So you have to follow the previous. For second iteration, you have to follow the first iteration. Okay, and then multiply by x1 is 1. Okay, y is 1. Alright, so the added will be 2.5. Okay, 2.5. So this one adaptation is 2.5. Right, so next for weight new 2, okay, O will be 0.5. Okay, and then 1. Okay, for this one, x2 is 1 and y is 1. So the answer will be 1.5. So this one will be changed. Alright, so 1.5. And then for weight 3, new, okay, with all 1 plus 0, okay, x3 is a 0, and then multiply by 1. 1 is a target, so equals to 1. So this one will be maintained, no adaptation for the weight 3. And then for last one is the bias. That's new, bias old is 2 plus y. Y is 1, so will be added 3. Okay, this one will be 3. Right, so this is for second iteration. That means the weight 1, 2 will be adapt and also the bias, but weight 3 will be maintained lah. Okay, so next you can proceed for the third iteration. For third iteration, same. Alright, first calculate the S, but make sure you use the new bias because follow the previous. Make sure this one follow the second iteration, this one follow the first iteration, and this one follow the initial condition. Alright, so now the third iteration, so the bias will be, okay, so this is for third iteration. Bias will be 3. 3 plus, alright, 1 multiplied by 2.5, okay, plus 1 multiplied by 1.5 plus 1 multiplied by 1. Okay, so that is the for the net input lah, for the S. Okay, so will be 3 plus 2.5 plus 1.5 plus 1, so will be 8. Okay, S will be 8, the net input will be 8 lah. Okay, here will be 8. And then you can calculate the weight new, with 1 new. Okay, so all will be 2.5. Okay, plus x1 1, y, okay, y equal to 0. Okay, so this one will be 0, so will be maintained 2.5. So for third iteration will be maintained. Okay, for second weight, okay, so 1.5 plus 1, 0, so will be maintained. I think this one will be maintained lah. Okay, the weight 3 new, all is 1 plus 1 multiplied by 0, because of the y is a 0. Okay, so we maintain. I think the third iteration will be maintained for the bias new. Okay, equals to bias all is 3 plus, okay, y is 0. Okay, so the third iteration will be same lah. Okay, will be same weight and bias. Okay, we same with bias. So that is for the herbs. Okay, for the herbs that I repeat again. So the step you have to calculate the net input. I think, but some of the question no need to calculate, just straightforward. You have to add the weight and bias. Okay, but this one maybe you can calculate lah, similar like this one. I just put another column, calculate the S here. Okay, but the standard is you have to calculate the net input, the S, and then you have to do some comparison. Y equal to T because of the target lah. Target equals to Y, the output will be equal to target lah. So this one, so I put another column here for Y. So Y will be follow the T lah, we follow the target. Then we have to adapt the weight and bias. Okay, this one we have to adapt the weight for every weight and bias. Okay, so that's the formula. This formula will be given for the midterm, for the midterm test for part 2. Will be given. No need to memorize. Okay, the formula. So the whole formula for the Merkelov, okay, for the Hertz, Perceptron, and also the Mendelin will be given. No need to memorize. No need to memorize the formula because the every, for example, like Hertz, they have the difference adaptation for weight and bias. Okay, also the Perceptron, also they have the different of the adaptation of the weight and bias, and also the Mendelin. That's why I think this one no need to memorize. Okay, but you have to know lah. Okay, this one the previous student, they are careless on this part lah. They mentioned to you. So on, for example, for the first iteration, you just follow the previous initial value. Initial value for weight and bias. For second iteration, we have to follow for the first iteration. Okay, for third iteration, we have to follow for second iteration for weight and bias. Okay, there's some clear mistake lah for the herbs. Normally, student, for example, for second, they follow the initial, so that's wrong. Okay, that is wrong. Or for example, go for third iteration, that also follow the initial condition is wrong. So you have to follow the previous. The previous is 2.5. For example, for iteration 3, so you have to follow the previous weight and bias is the 2.5, 1.5, 1, and 3. Okay, yes, that's all for the herbs. All for the herbs. So next we go for the Perceptron. for the perceptron. Okay, I copy screen first. Right, so next we go for the perceptron. We go for perceptron. Okay, all right, so this is a step for perceptron, similar like McCullough and Pitt. First, we have to calculate the net input. Okay, this is standard formula, SIWI, right? Then after you calculate this one, we have to get the output lah. So this one we have the condition. This is first step. Second step, we have the condition if S greater than threshold Y equals to 1. Okay. Next, if S less than threshold, greater than negative threshold, Y equals to 0. Okay, and then if S less than negative threshold, Y equals to negative 1. Okay, that is a condition to get the output. To get the output either 0, 1 or negative 1. Then third step, you have to compare. So if Y not equals to Y equal to T, no adaptation of weight. No adaptation of weight and bias lah. So we will follow the weight and bias. We will follow lah. So I will put here weight and bias. We will follow. Follow the previous. Okay, follow the previous weight and bias. Okay, follow the previous. Okay, weight and bias will be follow. But if Y not equal with T, so we have to adapt lah. We have to adapt. Okay, so this is a formula for adaptation of weight. I new. Okay, I all. Okay, plus alpha. Okay, so this one not given alpha. I will put here. So this one alpha. I just put alpha. Alpha equals to 0.5 lah. I put 0.5. So I'm missing on the alpha. Okay, not given alpha. So I'll put 0.5 for the alpha. Okay, target and xi. Okay, this one for weight new, and then for the bias new. Now bias new will be bias old. Okay, plus alpha t. Okay, so that is the difference. So for the herbs, they have the another formula, another formula to adapt the weight and bias. For the perceptron, they have also another formula. That's why the formula will be given. Okay, the formula for every technique on the simple neural network will be given. So no need to memorize the formula, but you have to know how to use. Alright, so we go for the first iteration. We go for the first iteration here. Okay, for the first step, we have to calculate the S. Okay, calculate the S. Put here S. S equals to, okay, so the bias is 1 plus, okay, with 1, okay, plus x2. X2 will be 0. X2 here will be 1, okay, plus 0, 1, and okay. So the answer will be 1, 2. Okay, answer will be 2. And then compare with threshold. Okay, y equals to 0. Y equal to 0 because of the range lah. Okay, so this is dimension. Okay, so for example, to get the range. Okay, so this one y equals to 1. Okay, this one. This is middle, y equals to 0. This means here will be 2. This one is negative 2. So less than -2 will be -1. So this one same. So this one s equal to 2 here. So y equals to 0. So we can put y. Okay, maybe here we can put y here. So y equals to 0. Okay, and then you can compare with next. You can compare with t. So this one y not equal. So the first station y not equal with t. Okay, y not equal with t. So we have to adapt the weight and bias. So I will try for the go for the weight one new. Weight one new. One old 1 plus alpha 0.5. Given alpha will given here 0.5. Okay, and then target is 1 multiplied by x1. X1 is 1. Okay, so will be 1.5. Okay, so the weight one will be 1.5. Okay, and then for weight new 2 new. Okay, all 1 plus x alpha x2 will be 0 and x2 target will be 1. Okay, so will be 1. So one will be 1. And then we go for the y3 with new 3. Okay, all 1 plus x alpha 0.5 x0 target is 1. Okay, so will be same Okay, only with 1 we will be changed. Okay, so we go for the bias new bias all 1 plus alpha 0.5 target is 1. Okay, bias will be changed lah. Alright, so 1.5. So 1.5. Okay, 1.5. So the weight for weight 1 and the bias will be changed. So the weight 2 and 3 will be remains same. Will be remain same as the previous. It's the 1 and 1. So next we can go for the second iteration. Second iteration will be same. Follow the same standard same sequence. Okay, first we have to calculate the S. Okay, yeah, I delete this one first. Okay, we go for the S equals to B. Okay, B will be B new. This is same like McCullough. Okay, same like Herbs. We have to follow the previous weight and bias. Okay, for the first iteration, we follow the initial. Okay, this is initial. 1, 1, 1. Bias is 1 is the initial, and then for second iteration we have to follow the second the first iteration. For the second iteration we have to follow the weight and bias for the first iteration. This one. For third we have to follow for second iteration. So that is some mistake from the previous student. So now B will be changed to 1.5. Okay, and then we go for x1 1. Okay, weight 1 also change 1.5. Okay, plus x2 1, and then weight 1 will be 1. Okay, plus x3 0. Weight 3 will be 1. Okay, so will be 1.5 plus 1.5. Okay, 3 plus 1.5 plus 1. Okay, so S equals to 4. Okay, S equals to 4 here in this condition. Okay, you can see this one this condition. Y equals to 1. Y equals to 1. Okay, Y equals to 1 here. Okay, so now you can compare Y here, Y not equal with T. So because of T is the -1. So that's why we have to adapt the weight and bias for new lah. We have the new weight and bias. Okay, so try for new one. New. Okay, all will be 1.5. Okay, alpha will be remain maintained 0.5. Alright, so target is -1. X1 will be 1. Alright, so will be 1. Okay, will be 1. 1.5. Okay, so this one will be changed to 1. Okay, and then weight 2 new. all 1, okay, plus 0.5. Target is the negative 1 and x2 is the 1. So this one will be right. So will be 0.5. Okay, so this one we change to 0.5. Okay, 0.5. So with 3 new. Okay, all will be 1. Okay, plus alpha 0.5. Alright, so x3 is negative 1, target is negative 1 and 0. So the answer will be 1. Okay, this one will be maintained. Maintain. Okay, and then the bias new. Okay, bias all 1.5. Okay, plus alpha 0.5 multiplied by target is negative 1. So will be 1. So the bias will be 1. So plus, okay. Okay, will be 1. Right, so next you can see this one. So the weight 1, weight 2, and also the bias will be changed. Okay, will be changed. But the weight 3 will be remain same lah. Okay, you can see this one. So next when you go for the third iteration, make sure you follow for the new weight and bias. Okay, so next we go for the third iteration. Let's go for the third iteration. Okay, for the third iteration, same. Calculate the S. Okay, B is 1 plus 1 multiplied by weight 1 plus 1 multiplied by 0.5. Okay, because of weight 2, 0.5. Okay, 1 multiplied by 1. So the answer is 1, 2, 3, 3.5. 3.5 greater than this one. Y equals to 1. Okay, Y equals to 1. Okay, this one, Y not equal with target. Okay, Y not equal with target. Okay, so for example, for this one, for example, if I change to this one, I put here 1. Okay, I put here 1. So this one, Y equals with target. So Y equals with target. So Y equal target, so no need to change the weight and bias, just follow the previous. So this one will be answer will be 1, 0.5, 1 and 1. No need to calculate lah. So just follow the previous. If the Y equals to T, okay, this one not this one before this is a 0 lah. So suppose Y not equal with T, so you have to adapt, right? You have to adapt the weight and bias. But this one I want to show you if Y equals to T. Okay, this one, for example, our target will be 1. So after calculate the S, so we get the Y equal to 1, and then compare Y equals to T. So no need to adapt the weight and bias, just follow the previous. The previous is the weight 1 is 1, 0.5, 1 and 1. Okay, that's for the iteration 3. Okay, iteration 3. Right, clear this one, All right. So next we go for the last part is the middle line, Middle line. Actually, the middle line is a combination of the other line. Okay, the concept for middle line is the follow the middle line. All right. So we go for the we for the last. Okay, try skip this one. Okay, follow for the last. Okay, learning rate. Okay, print screen first. Okay, so this is a middle line. Okay, the middle line. The middle line. So I just just focus for the middle line. Because of the other line, only focus only one neuron here. Okay, only one. The line we have more than one. Okay, for example, this one we have 3. We have 3 plus this one will be 4 lah. So this one maybe you can declare as the S1. This one S1, S2, S3, S4. Okay, you can declare as S1, S2, S3, and S4. Okay, the first step for middle line, I just explained for the middle line. Then we can go for the middle line examples. Okay, the first step for add line actually, right? So for add line, first you have to calculate the S. This is same, B plus summation of xi, wi. Okay, then compare. Second step will be compare. Okay, if S greater than 0, y equals to 1. Okay, if S less than 0, so y equals to, this one I will show you after this, y equal to 0 or negative 1. So this one that I mentioned to you in the previous class is the based on target data. Okay, so you can see this one. So our target data will be 1 and 0. The pattern will be 1, 0, 1, 0. That means you have to select the 0. Okay, no need to select the negative 1. So this one you have to select because of the target here. The target pattern will be 1 and 0. So no need to select the negative 1. Alright, so if S less than 0, so y equals to 0. Alright, y equal to 0. That's it. Okay, because of this one that I mentioned to you in the previous class. So you can choose either 0 or negative 1. Alright, so this one based on the target data, the pattern of the target. So this one we can see on the target. So only we have the 1 and 0. That means if S less than 0, so automatically we select the 0. For example, if this one we have the negative 1, just as example here, negative 1. Alright, so if we have 3 pattern here, so we have 1, 0 or negative 1 here. So we have 3 pattern here. So you can choose. This one you can choose. Either you want to choose the 0 or you can choose the negative 1. Okay, for simplicity, normally I will choose either 2 pattern, only 1, 0 or 1, negative 1. Okay, 1, negative 1 or 1, 0. Right? Okay, so that's after you compare. Next step, okay, the next step similar like okay, Perceptron. Okay, so y not equals, okay, y equals to t, so no adaptation lah, no adaptation of weight and bias. So y equals not equal with t, so we have the adaptation of weight and bias. So this is a formula for new weight and bias. So the weight all okay, plus alpha target minus s multiplied by xi. Okay, so and then for the bias new, okay, bias all, okay, plus alpha t minus s. Okay, so that's the formula for middle line. I think for the middle line also similar like the line. Okay, but for the that mentioned to you in the previous class, so for the other line they have the condition, stopping condition. So they have the error. Okay, you have to calculate the error lah. So the error for every iteration t minus, for example, error 1 so t minus t1 minus y1 lah. Okay, so for error total, you can call error total error 1, iteration 1 plus iteration 2 plus so on. Okay, we call it n lah. Okay, plus so on. And then you have to compare with E total, compare with E minimums. Okay, so if E total less than E minimum, then you can stop lah. You can stop the iteration. Okay, for example, first iteration you calculate. Okay, for the middle line, for the other line, calculate the E. Okay, E for this first iteration formula is t1 minus y1, and then compare with E minimum. If less, you can stop. If not, you can proceed for the second iteration. Okay, that is the step lah. The step for other line. But for middle line, that mentioned to you the previous class, so we skip this one. For middle line, we skip this one. Okay, we just focus okay, focus until this part. But for the real time, for real application, we have to consider this one. Okay, for every iteration we have to consider lah. Okay, consider for error for everyone, for every iteration. Okay, this one just skip. For the middle line, this one can skip. Okay, this one can skip first. Okay, for calculate the error. Okay, so we just focus for the so because of the we have the only 10 minutes, so I just skip this one. Okay, we go for the middle line. Okay, so for middle line, okay, first you have to calculate the S. Okay, maybe I can draw here S1. So you can make sure is the correct. Okay, so S1 will be here will be 0.4. Okay, another one 0.6. 0.6. Okay, another one will be 1. Okay, 1. Alright, so this is for output. For Y1, we can declare as a Y1. Okay, and then S2 I draw separately. Okay, 0.7. Okay, so this one 0.7, 0.8. The S2, declare S2, and then this here 0.9. Okay, this one will be Y2 lah. And then S3. Okay, 0.9. 0.9. Okay, this one 0.5, and last one 0.7. Okay, 0.7. This one Y3, Y3. Okay. So the iteration, okay, this one 1 0 0. Say 1 0 0 1 0 0 1 0 0. Okay. So next you have to calculate lah. Calculate the S for this one, S1. So calculate the S1. Okay, the bias one. Also this one I forget to put the bias. 1. The bias 0.8. So the bias is 0.9. Okay. So 1 plus submission of this one multiplied by 0.4. Okay, plus 0 0.6 plus 0 multiplied by 1. So the answer for this one is the 1.4. Okay, 1.4, and then compare. Compare, that means greater. So y1 equals to 1. Okay, y1 equals to 1. I put y1. So this one y1 equal to 1. So we go for the next second. For y2, calculate the y s2. S2, okay, by 0.8 plus 1 multiplied by 0.4 plus 0 multiplied by 0.8 plus 0 multiplied by 0.9. Sorry, 9. Alright, so 0.8, 1.4, 0.4, 1.2. Okay, 1.2. This one y2 equals to 1. So y2 equal to 1. Okay, and then S3. Okay, S3. Okay, S3 0.9. Okay, plus 1 multiplied by 0.9 plus 0 multiplied by 0.5 plus 0 multiplied by 0.7. Right, so we can get the okay, 0, okay, right, so 1.8. 1.8 y3 equals to 1. Okay, this means for S4 here, maybe you can okay, so I put here lah. So for the S4, the S4 here, so this one will be 0.5, this one 0.5. This is fixed, for the this is fixed for the second layer. For the header layer to output is the fixed to 0.5 for width and bias. Okay, this one will be 1. This one, okay, because of this output will be input for S4. This one 1. Okay, this one Y2. Okay, this one I declare as Y1, Y2, Y3. Okay, all the one. Okay, so we can calculate the Y4. We call it Y4. So calculate the S4 first. 0.5 1 multiplied by 0.5. Okay, plus 1 multiplied by 0.5 plus 1 multiplied by 0.5. Okay, 0.5, 0.5. Okay, so the answer will be 1 okay, will be 2 lah. S4 will be 2. Okay, so y4 equals to 1. Okay, y2 equals to 1. Then compare with target. So the next step we have to compare. So compare for the y4, the y4, not every y. So just compare the y4. So y4 equals to target. So compare with target. So our target will be 1. Okay, will be same. Will be same. So no adaptation of the weights and bias. No adaptation. Okay, no adaptation lah. That means you can proceed for the next iteration. Okay, the next iteration lah. Right. So no adaptation of the weight and bias lah because of the y4. Okay, the output here. The output we could declare as the y4 here. So equal with target. So no need to adapt lah. So we can proceed for the next for the next iteration. Okay, just we go for the next iteration. Okay, weight and bias will be same because of no adaptation. This one, okay, we go for the next iteration. Next iteration will be same. Okay, will be same, but the iteration will be different. 1 1 1 1 0 1 1 0 1 1 0. Okay, so this one you have to change now. Okay, so this one 1 plus this one same. Okay, this one 1 multiplied by 0.5. Okay, this okay, this one okay. All right, so the answer will be 2. Okay, the answer will be 2. So y equals to 1. Okay, y1 for second iteration, y1 equals to 1 here. Okay, and then for the next S2, okay, this is 0.8, 1 multiplied by this one suppose 0.7 okay, 0.7, but it's okay lah. I put 0.4 this one 0.7. Okay, this one 1 multiplied by 0.7. Okay, 1 multiplied by 0.8. Okay, and then this one 0 multiplied by 0.9. Okay, so 0.8 plus 2 point something lah. Okay, 2 point something. Okay, okay, 1.5, 5, 5, 5, 5, 5, 5, 5, okay, 2.3. 2.3, okay, y equal to 1 lah. Okay, this one y equals to 1 y2 equal to 1. And then next S3 be same. Okay, this one, okay, this one we change to 1 lah. Okay, so 0.9 sama 0.9 is 1. Okay, 2.4 2.4 y equal to 1. Okay, y equals to 1. Okay, so then you can calculate the S4. Okay, S4. Okay, I think similar lah because of the all the input will be same. Okay, will be same 1 1 1. Okay, 1 1 1. S4 will be 1. Okay, y4 will be 1. Okay, y4 will be 1. You can check here. Okay, then we can compare with target. So y4 for second iteration not equal with target. Okay, not equal with target not equal with target. Okay, then you can check. So our target will be 0. All the here, okay, not equal with target. So we have to add that for every weight so this one so we have for weight and bias we have to adapt weight and bias we have to adapt. Okay, we have to adapt. So that means we have 12. Okay, we have 12 parameter to be adapted. Okay, for second iteration 12 parameter to be adapted. Right, so and then you just for adaptation just substitute the formula. Okay, using the formula lah, substitute the formula. But this one I want to show so for example if y not equal with t, okay, so t is 0, but this one I just show some example. Maybe this one I change to maybe this one is the negative 0 for example negative 1 negative 1, calculate you can get negative 1, so y automatically will be 0 y will be 0. So you can compare. Okay, the y output is the not equal not equal. All right, so and then compare with which one not same with target. So only S2 y2 and y3. That means this part and this part you have to adapt. no need. For S1, no need to adapt because of we follow the target. Okay, follow the target lah. Okay, and then maybe another example here pun also I get negative 2.3 for example for S2 I also got negative 2.3. That means y equal to 0. So that means only S3. Okay, because only S3 we have to adapt because only S3 not follow the target. So we have to adapt only 4 parameters. Okay, the bias and the weights here. Okay, for this case, we have to adapt all the bias lah, all the bias and all the weights. That means we have 12 parameter to be adapted. Okay, for example this one because everything not follow the for the output this one not follow the target. This one is a 1 1 1. So our target will be 0. So all the weight and bias will be adapted. This one for some example this one is a 0, this one will be 0, only this part will be 1. Alright, so if y not equal to t, so this one same with target, y2 also same, y1 also same with target. So that I mentioned to you only S3, that means y3 not similar with target is 1. So only this part, okay, only this part we have to adapt, only this part on the S2. So this one will be remain for every iteration, the value for this, for the hidden layer to the output will be fixed to 0.5. This one, make sure, remember this one. This is some previous killer mistake. The student added this one. So this for S4, no need to adapt. If even y not equal to t. So this one will be fixed for every iteration. For we have 8 iteration. Okay, until 8 iteration. So this one no adaptation so no adaptation of the weights for after the hidden layer for the output. So this part will be fixed 0.5. Only S1, S2, S3 will be added lah, depends on the targets. If not same with targets, you have to adapt lah. So this one just for example we have 3. So if we have 8, just compare lah, which one not follow the target, you have to adapt the for every bias and for weights lah. Okay, for every weight and bias. Okay, all right. So that's all. And then you can try lah. You can try for the second iteration. For this one, actually we have to adapt the 12. Okay, this one the 4 parameter. That means we have 12 parameter to be added lah. You can try after this. You can try after this to adapt. And then after adaptation, you go for the next iteration. Next iteration, but the weight and bias similar like before this, you have to follow this one, the new one. So the initial, you follow the initial. Okay, the first iteration follow initial. The second iteration follow the first iteration. The third iteration follow the second iteration lah, the weight and bias. Okay, so this one you can try at home lah. Right. So that's all for our revision for our simple neural networks. But this one I not have enough time to cover, but you can try this one just for second iteration. You can try lah, adapt the weight and bias for every neuron here, for every neuron. Then you can try for the next, for the next iteration for that iteration S1 1 1 1. Then make sure the bias and the weight will be new lah, because the second iteration all the weight and bias will be adapt. So this one all the new value lah. Okay, so we have the new value here. All right, because of the second iteration we adapt all the value here. Okay, but this one, and I mentioned to you, this one will be fixed for third iteration, or we have the until 8. So this one, okay, for the hidden layer and to the output, the value is fixed for every iteration. It's a 0.5. Right, so that is some killer mistake on the previous. So they are changed. Okay, they are also adapt this one. Okay, this one no need for hidden layer to output. On this part, the bias and the weight will be maintained to 0.5, will be fixed for every iteration. If we have 100 iteration, this value will be fixed. Okay, make sure you remember this one. So this one, no adaptation of weights. Okay, only on the inputs to the hidden layer. Only this part we have to adapt the weight and bias, depends on the condition. Okay, all right. So that's all for today. So next week our class will be as usual on the Friday evening. All right. So, okay, thank you very much. Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, thank you guys. Okay.
Thank you, Doctor.
Thank you, Doctor.
All right.
Thank you, Doctor.
Thank you, Doctor.
Okay, welcome.